At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand that your performance is directly related to ours. Science knows why it works, care knows why it's important.
Welcome to the Magnalytix stand here at SMT AI. I'm standing here in front of one of the most exciting new products that was released at Apex earlier this year, and the two gentlemen behind this brainchild. We've got Mike Bixenman from Kaizen Corporation here on my right, and Mark McMean from STI Electronics. Now, combined, you both make Magnalytix.
That is correct.
Yeah. So, welcome, gentlemen, and congratulations. We can actually see it outside of a secret room today, which is nice. So tell me a little bit, just give us a quick catch-up on what has happened over the last 8 to 9 months since you unveiled this product in San Diego.
We officially launched the product earlier this year, and as we launched the product, Mark and I kind of were that team to try to get early adopters and into utilizing the technology. It's been a hard year because it's been a lot of work. I mean, from the standpoint, I often say is any new business is not for the weak and faint of heart, you know, because it takes a lot of work to get it off the ground. But what's interesting is that it's a technology that's needed in the marketplace because it truly helps people understand their products, their board designs, the different materials that they select within their process. It has a wide range of applications, and in many respects, it helps them understand, and then once they have that understanding, to utilize the tool ongoing to control their process. So it's really kind of exciting for me to be a part of it, to be able to work with somebody like Mark. It's just a big honor to be able to do that, and so it's been a lot of fun.
It's certainly a dynamic partnership, and we'll come back to some of the deeper applications you found for it in a moment. But I'm going to turn to you, Mark, to see about some of the development you've done since Apex by bringing in your own test coupons and cards and things like that. Can you tell us a little bit about what happened there?
Yeah, so the idea behind it was to find a good use factor. That is how can this be readily used by all manufacturers on the manufacturing production floor, the design centers, and how to bring it to life. And what was needed is the SIR test, as you see it behind us, is the OE200 came out at Apex. But one of the complementary things that spun off was the test card business. Right. So bottom terminated parts, QFNs by nature, are the most difficult to clean under and are the ones that are giving the industry the most degree of difficulty. Right. So the idea behind it was, could we build a low-cost test card system, right? The actual test card, the component sets, and everything that's needed to be able to gather the data of what's going on underneath the QFN part in real life. Right. So the SIR tool allows us to get the data, but the test coupons and the different types of parts going on them allows us to get the best functionality and the best use factor for the client. So that's what drove it to it, is because now we can take those component sets that are most challenging for the real manufacturer and the real card, and be able to get real data that's beneficial to the user.
Right. So are they on these test components? I mean, are they at different standoff heights, or is it just
you can make so you can make different standoff heights depending on their bump factor. So right now, QFNs with no bumps or no standoff heights will come in anywhere from 1.5 mils to 2.5 mils, and that gives us the cleaning challenge. As well, for the no clean guys, it gives them the ability to see what is their real SIR value underneath those component sets.
Right. Okay. Well, that's interesting. So you're making your own test coupons here, and you've got your own test system. that can very easily show whether there's a short under any of these.
So this is a shorts tester, and this is another complementary piece of equipment that goes with the OE200. You build your test card, right? QFNs, BGAs, you know, a QFP, whatever that may be. Once you build the card, you can plug it in and make sure that you don't have a short. In this case, we have a short on channel 3, right, to show that this one has some bridging from one of the pins, which means this particular one is shorted out. The same thing can be done, right, where you don't have the short, and this allows you to know that this card is ready to go in for your OE200 and run the SIR test.
Right.
So it was a quick way. As we develop QFNs that have finer and finer pitch lines, right, it's important for the manufacturer to be able to pre-test the cards to know that they're in an optimal state before you run the SIR test.
Right. Okay. So, just turning back to you for a minute, Mike. I mean, we spoke before we started here that we found some deeper applications for this, because initially I think you thought this was something that could be used in real time on the assembly floor, which of course it can, but you've found that it is even more useful to take it right back to the design stage.
Absolutely. When we started working on this project, Mark and I were also privileged to work with Doug Pauls at Collins Aerospace, and Doug is one of the forerunners of this whole test methodology. And Doug said, this unit could be used in PCB design and looking at different design features. For example, you could look at different laminates. You could look at different solder mask definitions if you wanted to, or metallizations, or in some cases, back to that QFN, you could look at putting encroached vias underneath that board, or different ways of raising that standoff, because the standoff is really one of the critical pieces of all this. The tighter the standoff, if you block the outgassing channels, you may not see the level of temperature that flux composition is designed for. You may leave active materials underneath it. So in the PCB board design, you can test those different design characteristics on that printed circuit board itself. As far as materials characterization, you can look at a lot of different material sets. You can look at any of your soldering materials. You can look at your soldering materials in combination if you have multiple processes, like you have the SMT process and a selective soldering process. You can certainly look at that. You can look at different cleaning materials and how effective are they on the material sets that you're trying to clean. You can look at the cleaning tools. This gives you the ability to say, how well does that cleaning tool clean underneath a particular component? You can make that assessment. You can also look at your process conditions. Another one of the interesting things about some of these test boards is we have an SIR comb that's located underneath the body of the component. What's interesting about that is you can now start to look at rinsing attributes of a cleaning process. In many respects, there's a lot of things on a board that could be problematic that you can't see. But with a system like this, you can detect it. So you can look at rinsing aspects, you can look at bath loading aspects. It gives you a lot of different characteristics. And then lastly, it's a tool that gives you the ability to do process control. Our code writers write all the analytics and statistics into this so that after each measurement, they're all updated and you can see them real time. So you don't necessarily have to run this test for 168 hours. You can tell on some of these boards within a few hours whether or not you have variability from lot to lot. So it's a very powerful tool that gives you the ability to make a lot of assessments into not only the design aspect, but on the production floor. And one other key area that I might note is that if you're on the production floor, an assembler can really make some assessments about their process quickly and gain some understandings, and it might help them, instead of making assumptions, to really have really good data to back up their decisions in the first place.
And I believe also, it's a very versatile product, but it also inspects under no clean. You can use it in a no clean environment.
On no clean, this is as powerful system for a no clean process as it is for a cleaning process. If you think about no clean requires a much more rigorous process because there are so many different areas in the assembly process that could invalidate a true no clean process. It's more than just the soldering material. So with a system like this, you can really look at your process in combination to know that if I am building a no clean process, am I truly reliable? And then lastly, you can even look at conformal coatings. You can look at, for example, if you conformal coat a board and you can set your chamber however you want to set it, you can look at moisture over time and say, how well does that conformal coating hold up to different moisture environments? Right. Or you can do like what MPL's doing, and you can do a moisture plenum where you bring condensation purposely to the board to look and say, what effect does that have on my assemblies?
Very important. Introducing this at the design level, though, is really going back to one of your early day wish lists, which was to be able to create design for cleaning. And you could essentially, the designers can really create a design for cleaning using this system.
Yeah, what's difficult out there is that a lot of these tests are not new. They've been around for a long period of time, but what most people did is they would validate a process with SIR, ion chromatography, and a different array of test methods, in the validation stage. And then when they put it in the production stage, they live underneath that validation for many years to come. But one of the things that is interesting is designs change and they become more dense. And as
sourcing changes all the time,
Yeah. And as that pitch becomes more narrow, your insulation properties are reduced. So this gives you really good insights into your designs and what could happen, what could change in my process. So and because you can bring it to the production floor, that's what it's designed to do. It really brings a layer of information that hasn't necessarily been available to assemblers in the past.
Okay, that's wonderful. So, Mark, just going back to you for a second on the cards. It's great that they can run the test cards, but there's also the situation of validating real life cards that they're going to be manufacturing. You also offer that as a service as well.
Right. So we have the ability also for real life cards to also put test coupons along the rails so that you can snap those off and put them into the test as well. Mm-hmm. So some people are actually building these little test coupons a part of their main hardware so that it's a full replication. You're just putting more difficult component sets along those snap-off coupons. And then you just use an AQL basis of snapping them off, one every 100 or one every 1,000 or one every 5,000, depending on what that quantity is. And now that allows you to get a snapshot of what the real boards are doing as they're processing through and getting real SIR data on that.
That's exciting. It's incredible how much you guys have managed to bring this product along in such a short pace of time. And I believe there's some new stuff also coming out at Apex, but I'm not going to spoil surprise for everybody. I just want to say thank you for joining us, guys, and we'll look forward to seeing your continued progress at Apex.
Thanks, Trevor. Appreciate it.
Okay, thank you. Thank you.